Alright, similar to the activity series, we can look at the halogen displacement reactions. And so if we take a look at this order right here, fluorine, chlorine, bromine, iodine, if you look on your periodic table, that's the family. So fluorine is on the top of the halogen family, iodine is on the bottom. So any diatomic halogen, which means a halogen bonded to itself, can take electrons from any other halide ion that is below it in the family. So fluorine can take from any of the other guys. Chlorine can take from bromine and iodine. Bromine can only take from iodine. And iodine, that little wuss, can't take from nobody. So chlorine gas is bubbled through an aqueous solution of potassium bromide. So let's write this out. Chlorine gas, that's going to be Cl2. It's one of the diatoms. And gas, which means it's G. It's bubbled through a solution containing potassium bromide. Hey, potassium, group 1 metal. It's a solution. That means it's a spectator, so let's just look at the bromide. Br-, solution, which means it's aqueous. Now, if you look on your periodic table, chlorine is higher than bromine, which means that chlorine is going to be able to take electrons away from bromine. Now I'm going to show you a long way to do this, and if you're struggling a little bit trying to figure out what the reactions look like, this would be a good place to start until you get familiar with it. So let's set up the half reactions and look at just Cl2 at first. So Cl2, when it gains electrons, is going to turn into Cl-. And so since it's Cl2, that means there's going to be 2 Cl-. So in order for Cl2 to turn into Cl-, how many electrons would we need? We would need 2 of them. So Cl2 plus 2 electrons would give us Cl-. Now let's look at the bromide half of the reaction. We've got Br-, and it needs to give up 2 electrons, so it can turn into Br2 plus 2 electrons, which means we need 2 bromides. Now if we add these two reactions together, we can see that 2 Br- plus Cl2 is going to yield for us Br2 plus 2 Cl-. And those 2 electrons, same on both sides, so they were given up and then absorbed, so really they don't change. That means our overall reaction is just going to be this bottom guy. So in a hydrogen displacement reaction, alkali earth metals, or the alkaline earth metals calcium, strontium, and barium, can displace hydrogen from water. And so what they're doing is they're turning the oxidation state of hydrogen from +1 to 0, which means that hydrogen is being reduced. So it's gaining electrons to go from the oxidation state of +1 to 0. When this happens, you generate hydrogen gas, which comes off as bubbles. So here would be an example of that: sodium metal placed in water. So we have just straight up in a solid, and it's being placed in water. Once again, going kind of the long route on this one, let's take a look at the two half reactions. So look at water first, because we saw that in the last slide. So we have 2 H2O gaining 2 electrons to form H2 plus 2 hydroxides. And then sodium. Okay, so if hydrogen is gaining electrons, it means sodium has to be losing them. And we know that sodium can turn to Na+, which means it loses an electron. But in order to balance out, notice we have 2 electrons here that need to be picked up by the water, and only 1 down there. So that means we need to balance this and say 2 sodiums lose 2 electrons. Then if we sum these two together, obviously the 2 electrons cancel each other out. The overall reaction would be 2 waters react with 2 sodiums to produce 2 Na pluses plus H2 gas plus 2 hydroxides.